In this video, we're going to figure out how to determine an equivalent discount rate to a given interest rate or an equivalent interest rate to a given discount rate. I'll step off the screen. Please pause the video, copy the notes down into your notebook, and then I'll start up again. All right, well, we say that two rates of interest, be it interest or discount or later on force of interest, two of these rates are going to be equivalent if they both lead to the same accumulated value, ADT, at any time t, all right? So they both move money through time in the exact same fashion, all right? So let's recall the compound interest, compound discount formulas we have. For compound interest, we could compute the accumulated value at time t by taking their present value and multiplying by 1 plus I to the tth power, all right? For compound discount, the basic formula we had memorized was for the present value. Our present value is arrived at by taking the accumulated value and multiplying by 1 minus d to the tth power. But I could divide the 1 minus d to the t underneath the PV0, and I now have an accumulated value with discount, okay? All right, so I is the effective rate of compound interest per time period, d is the effective rate of discount per time period, and oftentimes in the examples it's been per year, but if everything is per month, nothing changes about the formulas. As long as we're all agreeing that our time period is 1 month now, we can use the same formulas. Or if everything's in terms of weeks, we're good to go, all right? And then t is the number of time periods, be it years, weeks, months, what have you, okay? All right, well, if I want to figure out what I value is equivalent to a d value, I'm simply going to set these two accumulated value expressions equal to each other right down here. I can divide both sides by PV0, not going to both out. I can then take the 1 minus d to the t and multiply it over to the left, leaving a 1 all by itself on the right. And on the left, both terms are to the tth power. So I can drag that t further out in front. So I have 1 plus I minus t quantity to the tth power equals 1. And then if I take the tth root of both sides, well, the tth root of 1 is just 1. So I get 1 plus I times 1 minus t is equal to 1. And that's the central formula to memorize and to keep in mind, okay? That's how we're going to convert. And the way I remember it is, well, 1 plus I pushes you forward a year, 1 minus t is what brought you back a year from a previous video, and should get you to the same spot of $1 of initial loan amount. All right, so that's the equation we're going to use quite a bit. Now, if you like, you could divide the 1 minus d underneath the 1 and come up with this alternate formula. Or you could divide the 1 plus I underneath the 1 and solve for 1 minus d. And the only thing that's nice about that is you might recall that 1 divided by 1 plus I was what v was defined as. That's how you move money back a year, all right? So you got 3 formulas, but honestly, that's the one you memorize. And then you also know that v is simply defined to be 1 divided by 1 plus I, okay? So you can convert between all 3 of them now. So, for example, we are told the annual effective discount rate is 3%, and we'd like to determine the annual effective interest rate and the value of the discount factor, v. And I've never called it a discount factor before, but we'll see why it's called that in this example. So we've been given that d is 3%, and we're trying to figure out I and v. So there's our formula, 1 plus I times 1 minus d equals 1. I can replace d with 0.03, divide 1 minus 0.03 to the underneath the right-hand side. And if I solve for I get I is equal to 0.03093, which is slightly more than 3%, okay? And your interest rate should always be slightly higher than your discount rate, okay? We can also go ahead and calculate v in one of 2 different ways. So I know I, and I know that v is defined to be 1 over 1 plus I, so I can replace I with 0.03093, and I get 0.97. Or I can recall that v is equal to 1 minus d, and d was equal to 0.03. So v is equal to 0.97. And it's that fact that v is equal to 1 minus d that makes this called the discount factor. If you multiply $1 by 1 minus d, it drags it back, it discounts it. And that's what v does as well, all right?